So we've got this lovely notation that we use in maths. It's a sigma sign, the capital Greek sigma sign, looks like that. You might have seen it in statistics, maybe at GCSE, maybe if you're doing statistics with your A-level, you might have seen it like this. This is the average.
Yeah.
You may have seen that. So this means add up all the x's. So essentially, you can think of the sigma sign as being used to mean add up, essentially. Okay. So in the pure maths context, this is the sort of thing you see. Now, initially, to someone who doesn't study maths, this looks really confusing. This is the sort of thing, if you want to, your parents think you're super clever, just leave bits of paper around the kitchen with this written on, and they'll just think you're a super genius, because it does, to a non-mathematician, look confusing.
Yeah.
But essentially, it's telling us to add some stuff up. That's all it's saying now. Okay?
Which is basically the easiest
Which
thing
is
to do, yeah.
exactly really easy. So we'll just go through how you unpick what this notation is actually telling you to do, and then hopefully you'll be able to do these sigma notation questions without your brain scrambling and you getting all confused, because they're not difficult. So we know that this means add up, the sigma sign. Add up.
Yeah.
Okay. At the bottom, we've got k is 3. Now, the k here is the same as the k here. It's just telling us that that's what we're looking at. And we're told that k is 3. And now, k isn't always going to be 3, but we're going to start with k is 3. So this thing here, this means add up. I'll change colour maybe. The k is 3 means start with k is 3. Now, you've also got at the top a 6. Now, this actually means k is 6, but we don't bother writing.
A bit lazy like that.
Yeah, because we've got it there, so we know we're talking about k. So the bit at the top is stop when k is 6. That's what that means. And then, obviously, we're starting with k is 3. We're going to go k is 4, k is 5, k is 6. Then we're going to stop. But obviously, we need to know what to do with k, and this is what we do with it. Do this with your k values, whatever that thing is, okay? And then add them up. So let's have a go. We're going to start with k is 3, and what we're going to do with it is 2 lots of k minus 1.
Well, so that's 2 lots of 3 minus 1, which is 5.
Yeah, 5. And then we're going to do k is 4.
2 lots of 4 minus 1, which is 7.
Yeah.
Took me a moment.
And then you literally just keep going until you're told to stop, and we're told to stop when k is 6. Excellent. And then what we're actually doing is adding these up. So what we, yeah, exactly, add. So this says, what is 5 add 7 add 9 add 11? Now, to be honest, we can just, even I can probably do that in my head. 20, 32? Yeah. Done, 32. So it looks complicated, but it's not that complicated. The sigma sign means add up. At the bottom it tells you what to start with. You go up and up in ones until you get to the thing that you're meant to stop at. And then the function in the brackets tells you what you're actually doing with your k values to get your numbers. And then you add them up.
Yes.
So, you know, really, just don't worry, do what it says. Add up these numbers. Start with this, finish with this, and add them up. Okay, so shall we have a go?
Yep.
Okay, so what are we going to start with? Oh, it's r instead of k. So
Oh, it's still the same.
yeah,
they're the
yeah.
same.
So we're going to start with r is 10.
R is 10, so that's 70 plus 2, which is 72.
Yep, then r is 11.
70, nope, normal, 77, plus 2 is 79,
Yep, now r is 12.
is 12 would be 86,
Yep,
and
R is 13.
13 is 93.
Yep,
Yeah.
r is 14. And we're going to keep going until we get to 142, right?
Really? 100.
Yeah. Okay, so let's just, in a minute, I mean, obviously, you are going to keep going until you get to 142.
It's going to take me all afternoon.
Yeah, but that's what we have to do, you see. So we're going to stop at 142. So what would that give us? 7 times 142?
Well, 7 times 140 is 2,100. It's 14. No.
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 Okay, what about, because I do chunking, what about 7 times 100?
It's 100.
7 times 4 is 28, so 7 times 40 is 280, and 7 times 2 is 14, so 7 times 142 would be 994, yeah, and then add 2 would be 996. Is that right?
Yeah.
Okay. So there's obviously quite a few missing here, and you're hoping we don't have to actually work them out. And then
add them.
we've got to add them, exactly. So what are we actually meant to be doing here? We're meant to be doing 72 and 79 and 86 and 93 and 100 and loads more, add 996. And this is in C1 without a calculator.
I don't want to add that up.
No.
I guarantee you I'm good one.
Yeah, no, I'm not adding that up. So, what type of series is this? How would you describe that?
It's arithmetic.
Is it though? Is it?
Well, you add in 7.
Yep.
And then you add 7.
Yep. Okay, it is an arithmetic series. Great. Well, if it's an arithmetic series, we can use the arithmetic series formula for adding them up.
Yeah.
You can't if it's not an arithmetic series. Not add 9, I think. But because this one is an arithmetic series, that is great news because we know a formula. N over 2, 2a plus n minus 1d is the total.
If you've forgotten that, go back to the video.
Yes. So n is, what's n? How many terms were there in this sequence?
Well, if we've gone from 10 all the way up to 142, over 132 terms.
That's what you would think. Yes. But let's have a look back here. Now, we started at 3, finished at 6. So the tempting thing is to say that there were 6 minus 3 terms. 1, 2, 3, no, 4 terms.
Because you actually count that bottom one, don't you?
Yeah, because we included 3, didn't we?
Yeah.
So what have we not included? We've got k is 6, k is 5, k is 4, k is 3, not k is 2 or k is 1. These are the ones we didn't include, those bottom 2, but we did include k is 3. So going back to the one we're looking at now, which is this one, what we haven't included is r is 1, r is 2, r is 3, r is 9.
Yeah.
9, there's 9 we haven't included, not 10. So the number of terms is 142 minus 9, which is 133, not 132. So n is 133, a, the first term, 72. N is 133, so n minus 1 is 132. Common difference? 7. What was the other formula that we had? Do you remember? There were 2 different ways to think about it. First and last. So we still need to know what n is, 133. First term? Last term? Might be easier. Either of those is fine. But
Still horrible.
it's still horrible, I agree, it is still horrible. I don't really want to do it, but I will. But yeah, it's still horrible. Okay, which one? Should we use this second? That one?
Yeah, I think so.
I think that's nicer, to be honest. Okay, so it's 133 over 2, 72 and 996.
I want to do that bit first because that's going to be even.
Yeah.
Yeah.
So it's 996 add 72. Agree?
Yeah, I do.
So it's 133 over 2 times, to be honest, I'm going to write this as a fraction, 1068 over 1.
Yeah.
And then what we can do is write that as 133 over 1 times 1068 over 2.
Mm-hmm.
It's the same thing, right?
Yep.
So what on the top, 133 times 1068.
You multiply them, don't you?
Yeah, on the bottom 2 times 1, 1 times 2. But like you quite rightly said, because this second one is even, that that means we end up with 133 times 534. I don't even want to do that. Do you want to do that?
Right, okay, so we've got 100 times 534, which is 53400.
Yeah.
Then we've got 3 times?
No.
3. Yeah, no, do 3 and then we can do times 10 then.
Yeah.
So, oh goodness, here we go.
Add it up 3 times?
34. We'll do it that way, I don't know.
I would do 534 added up 3 times rather than timesing by 3. 1602?
Yeah.
Same as you.
Yeah.
Yeah. Okay.
Either way, it
So,
doesn't matter, does it?
3 times 534 is 1602. But didn't we want 30 times?
Well,
So
then we just do 30, can't
yeah.
we?
Oh yeah. And then okay, so then we would want 133.
Yeah.
So that's going to be them added up.
Right, so that's 0, 0. I haven't put these in very good order. Right, 0, 0, 2, 2, 10, 16.
Wasn't that one?
0, 4, 10, 0. No. Yeah.
We didn't add these up right there. The 0 and the 2 and the 0 is 2. The 0 and the 0 and the 2 is 2. The 4 and the 6 and the nothing is 10. And then it's 3 and 1 and 6 and 1.
11.
Yeah. And then it's, so that was that. And now it's 5 and 1 and 1.
7.
I think.
Yeah.
I think that's it. 71022. If you're at home and you've got a calculator, you could cheat. But in an exam, obviously, C1, no calculator, you do have to do this. Okay, so let's think. What was difficult there? Look at that enormous page of work, and what was the actual difficult bit of that?
Well, we were looking like we were getting a bit headachy here, thinking we were going to have to add up some 100 and something terms, but really we only needed the top one and the bottom one.
Yeah, exactly.
Then there was a little bit of brain power to realise that that number there was 133, not 132.
And also
Bit of a mistake
the
again,
big
really.
step of realising that we had an arithmetic series so we could use the formula.
Yeah. So, but it wasn't exactly difficult, it's just keeping
Yeah.
aware that you
Yeah.
might get that kind of thing.
Yeah.
Actually, really, this was the maths bit, I think.
Yeah. Numbers.
Numbers. Just
Exactly.
awful. Right?
Yeah. Let's try one and hope it's a bit easier.
Oh, that's nice. Okay. So this is telling me to take 2 and raise it to the power bar.
Yeah.
R is 2, so we're going to get 2 to the 2, which is 4.
Yeah.
Then R is 3, which is 2 to the 3, which is 8. And then R is 4, 2 to the 4 is 16. I wouldn't have gone much higher, but thankfully we have to stop there.
Stop it.
And then sigma means sum. So that's 4 plus 8 plus 16, which is 28.
Yeah. Yeah, 28, yeah. And just a reminder, because this is a sticky point usually with students, if it was an arithmetic series, which it isn't, you don't, because this is add 4 and this is add 8, so it's not an arithmetic series, but if it was and we were trying to find out how many terms there were, it is not 4 minus 2.
No, it's
No, not 4 minus 2. The number of terms is 4, take away how many we didn't use, and here we didn't use R as 1. So the number of terms is 4 minus 1, which is 3. 1, 2, 3 terms there. Okay, last one. Oh, recurrence relations, in with sigma notation. Okay, now just remember, sigma notation and recurrence relations, it is simple, you just need to calmly read it. So go ahead and go to the sigma notation first.
right.
You know
So
how
what
to use
this is
sigma
saying
notation.
is,
First K is 4.
yeah. So we've got 3UK, 3U4,
3U4, yeah.
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 And then we're adding that because it's sum
Yeah.
to 3U5,
Yeah.
and then we're adding that to 3U6,
Yeah.
and then we're going all the way up, but we're stopping at adding the last one to 3U10.
Yeah, exactly. Yeah.
So that's what the sigma's telling us.
Yes, that's the sigma bit done, essentially. So do we know what U4 is, or U5, or U... We know what
Well,
U1 is.
Yeah, well, we know what U1 is, which is 4. And then we know that to get U2, we're going to do U1 plus 5,
Yeah.
which is 4 plus 5, which is 9.
Yeah, that's U2, but we want U4.
Well, we're going to have to keep going, aren't we?
Okay.
So U3 is U2 plus 5, which is 9 plus 5, which is 14.
Yeah.
So then U4, I think I'm getting the pattern here, is 19.
Yeah, 19.
So we've got 3 lots of 19. And then, because we're just adding 5, it's like an arithmetic, isn't it? So we've got 3 lots of 24 plus 3 lots of 29 plus whatever that one is, which is 3 lots of 5. N minus 1 and minus 1, right?
I think that bit you did there was a bit clever. I think
sorry.
so. What you've done here is you've said I've got an arithmetic series.
Yeah.
You've said the first term is 4.
Yeah.
You've noticed that the common difference is 5.
Because every time we're just adding 5 to get to
And
the
then
root
you
one,
had
yeah.
a question, what is the 10th term? So what you did that was clever was you said, well, the 10th term is a plus 9d.
Yeah.
So that's 4 plus 9 lots of 5.
Yeah.
And there's your 9 and there's your 5, but I don't think you did 4 plus. Yeah, there we go. There we go.
There it is.
Yeah. So sometimes it's good to kind of break away
Yeah.
and do that almost as a separate thing to say what would the 10th term be. It would be the first term, add 9 lots of the common difference, which you've realised is 5. So that gives us 49.
Yeah.
So the 10th term, U10, is 49. So, I mean, the sigma notation bit was fairly easy, just
Yeah.
meant add up. The recurrence relation bit, the first term is 4. We needed to know what's the 4th term, 5th term, 6th term, 10th term. We've done that quite easily. We just need to think now, how are we going to add them up?
Okay, well, let's write them out, shall we?
Yeah.
So, could we factorise out the 3? Would that be more sensible?
Yeah, that's a good idea.
Because I don't really want to multiply everything by 3, but it's all going to... So then we've got 19 plus 24
Yeah.
plus 29
Plus dot, dot,
plus
dot.
plus 49. I'm feeling
Yeah.
another arithmetic sequence.
Yeah,
to be honest.
exactly. A different one.
So we've still got a gap of plus 5 here.
Yeah.
So we know that our D is 5. A is 19.
Yeah, because we're looking at a completely different series
Yeah.
now.
Yeah.
Our question now, our question a minute ago was what is U10, so that we knew what this was.
Yeah.
Our question now is what do these add up to?
Because we're still trying to do
Yeah.
what's the sum.
Yeah.
Yeah.
And we know that we can add up an arithmetic series using n of the 2 first plus last.
19 plus 14.
There we go. And n is number of terms.
Which is 10 take away 3.
Yeah, exactly, yeah.
So it's 7.
Yeah, 7.
So that's now n of 2 is actually 7
Yeah.
of 2.
I mean, if you don't believe us that the number of terms is 10 minus 3, we could just write them down. It's
U4.
U4, U5, U6, U7, U8, U9, U10. 1, 2, 3, 4, 5, 6, 7.
Yeah.
But the best way of thinking about it is like we just did. You're thinking U1, U2 and U3 have been chopped off from U10. So 10 minus 3 is 7. Yeah.
Okay, so this is pretty horrible, but it's okay, isn't it? It's nothing.
Yeah, it's just numbers, isn't it? It's what's hard about this is the fact that you have to add up.
I hate
49 plus 69
Well, take
minus
that
68.
68. Yeah.
Oh, same as before.
Yeah.
You've got,
So that's like 7
7.
over 2. 68.
yeah,
1.
which is the same as 7 over 1.
68 over 2. 68 over 2, that's 34, isn't it?
Yeah.
7 times 34. Well, 7 times 30 is 210.
Yeah.
And 7 times 4 is 28.
Yeah.
That's 238.
238, yeah. So that's that bit in the brackets, yeah?
Right, so we've still got 3. We
Yeah.
haven't done anything with that.
Yeah.
We've now got 238.
Yeah.
And that is the sum
Yeah.
of
That whole original question.
that whole original
Yeah.
question. Yeah.
I would do that by adding it up 3 times. I'd
Do you
go,
really?
I would, wouldn't you?
No, because it's only one number on the
I'd
bottom.
do 238, 238, 238, and then do that.
Oh, because it's just one number there. It's so easy. 8, 24, 9, 11.
Well, we got the same. So
Yeah, that's good. Yeah. So
Brilliant.
that the sum of this
Yeah.
whole massive thing,
Yeah.
when you have that recurrence relation
Yeah.
is 740.
Yeah. Yeah. Now, as you can see, we've made a right mess.
Horrible.
It's horrible. And if you're an examiner and you see 714, then probably you just give it full marks because
You've got to.
there's loads of method
Yeah.
and you've got the right answer. But say we went wrong somewhere, just we made a tiny little error, which of course is easy because there's so many numbers, and then you end up with 621. You got the wrong answer. It's chaos.
Yeah.
No one can work out what on earth we were doing there, and the examiner finds it really hard to find out what you were doing. So one of the things that's really important is to try to really write neatly, write what you're doing, show all you're working, explain to the person reading it and to yourself what your thought process is.
I mean, when I was doing this exam, I used to write out like a little sentence. So
Yeah.
I'd be like, I'm looking at the sigma notation, and I'd write that in here. I'm looking at the sigma notation. And so then they could see that what I'd done was I looked at this and expanded it out. And then it would be like, I'm now using the recurrence relation. And it felt really laborious at the start to write all these steps out. I'm going, I just want to get through the question. But actually, when you go back and check,
Yeah.
you've got a commentary to yourself, and you
Yeah.
can be sure your examiner knows exactly
Yeah.
what you're doing.
I mean, you see, I think all of the ones we've done just now, oh, that's not too bad. But even that, so not, well, that's all right. So that's horrible. That's all over the, I mean, yes, we've got the right answer, but you can't read it. So do try and make your answer nice. Imagine you're writing it out for someone that doesn't know how to do it.
And you want them to be suitably impressed.
Yeah.
They're
and
not
you-
going to be impressed by this.
No.
test.
If someone said to you, how did you do question 7, and you gave them this piece of paper, there's no way in a million years they're going to understand what you did. And that's not what you're going for. So try to write it much more neatly than we did.